Okay, so forklift will lift big, heavy things. But also can move. And sometimes that movement and that lifting is in conflict with each other, and it will lead to a failure like this. Right? And so good systems engineers will try to figure out all this stuff. They'll quickly identify that, I think it's kind of obvious that the mass of the load is very important, but especially the mass of the load compared to the mass of the vehicle, the red thing. Right? And it turns out, tire friction is important. The friction between load and forks is important. And, the driving of it, are you driving it from the front axis or the rear axis? That's important. So lots of important, I'll say design choices need to be made to kind of make sure this thing functions as we intend it to. All right. And I'm going to give a quick endorsement to this tool. It's called Working Model 2D. And it focuses on 2D mechanics, and I'd say in my career of doing this for like 25 or 30 years, I'd say the 2D mechanical problem is really important. Certainly the forklift in this study fits that description quite well. The other thing about 2D is contact modeling in 2D is way easier than it is in 3D. All right, and we'll see that this little analysis we did, I think this was about as good of a tool you could do it with. All right, so anyways, we'll do additional video where I'll show how this was created. And again, because of that optimized 2D interface, I was able to build this very quickly, probably like 5 minutes or something like that. So anyways, but we live in a three-dimensional world, and to create something that will exist in the real three-dimensional world, we will need to kind of consider it that way. And of course, there are failures in 3 dimensions as it goes around a corner. You could get centrifugal loads that will lead to the tip over as well. So lots of obviously important reasons to move to 3 dimensions, right? And so here's kind of the mechanism to get there, right? And so this is the tool called SimWise. I've done lots of videos with SimWise, and it's clearly a 3-dimensional tool. It's based on the geometry that we had in 2D. I'll just kind of show that. And the original name of SimWise was Working Model 3D, and it was kind of built by the same people who did 2D, and it has this feature to open up 2D files. And really, there's one question that it asks you when you moved into 3D, which is, how much do you want to extrude it? And I chose about 1.5 meters to put that 3rd dimension in. Right. So on this side, I put tires on both sides, and I put multiple forks, so there's a little bit of effort to kind of get to this. But once we get to this, now we're kind of in this 3-dimensional world, and it turns out that the many important tools out there that do 3-dimensional mechanical simulation, they all kind of work off the same kind of format description, and that's a description that quite often goes by the terms bodies, joints, and coordinate systems. And so bodies are essentially the physical things that have mass, inertia, 3-dimensional geometry, and so forth. The joints are the things that kind of connect these things, and they include, welds, but, motors and axes that allow rotation, and even the kind of sliding up and down of the platform for the fork. So, and then coordinate systems, it's a big deal. It's a real big deal in 3-dimensional mechanics. And in general, they do lots of things, including marking locations for joints, but certainly measurements and all kinds of things are based on this idea of XYZ Cartesian coordinate systems. All right, so I'll just kind of show where this is, and it's called motion results. And if you go here, you'll see that there's an export, and it's an XML. And XML just means, it's a common, format for describing hierarchical structures and bodies, joints, coordinate systems really fit the bill to be described quite well with that. All right, so once we get that kind of description defined and captured, that's what facilitates our ability. That plus I'll call these neutral geometry formats to kind of get this into kind of the right packages that will launch the design processes for both mechanics and I'll say also just kind of the systems and the controls and the operational software that will run a vehicle like this. So So anyways, through the neutral file format, I believe it was ASYS, I was able to bring it into SolidWorks. And hopefully that's enough to kind of show that, well, once I can get it here, certainly I can do all the great things you can do, not just in SolidWorks, but any of these CAD tools to design mechanical systems like this. All right. Now the other one for me was, of course, MATLAB and Simulink. And so, very rapidly, I'll follow up this video with a few videos to kind of show how these things took place, but very rapidly we got it into Simulink. And I just want to kind of bring, there's the animation, and I'll say, oops. Okay, let's just kind of run this. And very quickly, we kind of, have it doing all the same things that we really set up on the working model 2D side. And again, that took just 5 minutes. But once in Simulink, we got access to, measurements of almost anything, and we can fully analyze it. And through this analysis, we can we certainly will create the software that will operate the system. It will protect this system. It'll make sure that I'm not rising my forks too fast, or I'm not traveling too fast, so that there will be a conflict that can lead to a dangerous, failure, like the whole vehicle tipping over. So anyways, this is a video where I just want to kind of lay out some of the really important tools and the advantages, of taking a simulation approach with, the various platforms. And of course, I work for MathWorks, and I recognize that MATLAB and Simulink is a critical simulation platform, not only for designing software, but bringing those scenarios and those controls into the mechanical design processes too, so that we figure out the right requirements and design all, the complete system, to perform optimally and meet all of our requirements. Thank you for watching.